Hello, welcome to this presentation about designing a Makerspace lessons. My name is Ko Chung Wong. This presentation is divided to 4 sections. The first, introduction, the lessons, standards, as well as learning objectives. Second, I will be talking about differentiation strategies, then the Makerspace and its benefits of integration, and last, the feedback and summary. In this section 1, I will explain more details about lesson plan, the objectives, curriculum alignments, and relevant standards. And I always tell my students in class, gigs is the new cool. Without further ado, let's head to the future. This lesson is designed for grades 10 to 11 and 12 high school students. In previous lessons, students already learned and have some strong foundations in some of the engineering topics, such as overview of DC motor, Arduino Uno components, and so on. In this lesson, students will take on the Arduino Blink Challenge, learn about how computer and software engineers to solve the challenges of a society, such as providing systems for turning lights on and off automatically. Students work in teams to set up and program to turn a light on and off at a 5 seconds on and 2 seconds off interval. There are 6 objectives as shown, and 3 of them are actually the life hack skills or maker mindset, and they are learn about engineering design and redesign, learn how engineer can help solve society's challenges, learn about teamwork and problem solving. Lesson plan in this course is aligned to one or more of the following set of technology and education standard organizations. The following 2 pages are the details of content standards that corresponding to each organization. Section 2, differentiation strategies. I tend to be open to transformations ideas. This provides students with flexibility options from subjects or topics to approach or presentation. The contents they study to meet the objective and standard. Students will use the SMART to look at our goal and use STEM vocab to communicate in project, and we will break down our objectives into engineering design process with necessary steps in individual engineering notebooks (EN). For example, project ideas, research, interviews, sketches, calculations where everyone speaks the same language, and professional engineering vocabulary with the SMART. Everyone's achieve goal by the expected deadline. Here is the definitions of Makerspace by Dell, the founder of Mac magazine. It is a space where kids have the opportunity to make these places called Makerspaces. In Japan, the idea of makerspace is a common practice in daily life called kateka ki jibunya, and it has been taught in elementary and middle school since 1947. Let's get started with Makerspace. In Section 3, Makerspace integration into learning, where we can see how students' ideas being materialized. Pictures and videos from left to right, number 1 to 9, where different stages of students' engineering design process and their final product has been 3D scanned and archived for future reference and study. This has been archived in our school cloud, which can be viewed on any computer or AR/VR goggles. Majority of students were able to achieve all the 6 stages in the Part 1 SMART engineering design process. Students are also able to apply the SMART strategy with logical computation thinking and articulate their idea with the engineering vocabulary. Here are the examples and activities of how our students, or I should call them our future engineers, work on each stages. The part 2 is the homework. I've included some of the engineering design challenge where students have to apply their critical thinking about what-if scenario-based questions, and the students' reflections, which is the part of the engineering notebook, where guided questions such as what challenges do you have, if any? These questions can be software programming, hardware, team communication, and so on. engineering in reverse work of students, where we can see how students were able to reverse engineer their device and explain to the class how device work. Use the projects in a meaningful lessons such as step-plus example on the right. Encourage a different learning style among students and peer learning. Section 4. Feedback and summary. Feedback were overwhelming, and overall they enjoyed task-specific lessons with freedom to explore solutions that have the life hack elements and practical to their life. They also like about the idea of reuse their past projects and improve them. With learning the smart engineering design process, there's nothing goes wasted. Reflections. My definitions of Makerspace is a place where ideas, communications, and knowledge are connected. Teachers must not limit to creating or making, but sometimes breaking and modifying are also part of the learning. Makerspace is about the one place where wisdom, understanding, and knowledge, as well as teachers and learners, are enjoying the process. Here's the end of my presentations. Thank you for watching.